What is React's core magic anyway? Well, it's all about how efficiently it updates the user interface. And the secret, it all starts with something called the virtual DOM.
Okay, imagine the real DOM in your browser is like a heavy physical building. It's slow and really costly to make changes to. So instead of constantly messing with it, React works with the super lightweight blueprint in memory. It can make thousands of changes to this virtual copy almost instantly, and it costs absolutely nothing in terms of performance.
And this process, this is the entire secret sauce to React's speed. When something changes in your app, React doesn't just bulldoze the house and rebuild it from scratch. No way. It follows this really clever four-step dance. An update gets triggered, it makes a new virtual blueprint, it finds the exact tiny differences, and then, and this is the key, it applies only those minimal, surgical changes to the real DOM.
So knowing how React works is one thing, but knowing how to use that to make your application lightning fast, that's another. So let's move on and see how this all builds into practical strategies that you can actually use.
Here's the key to optimization. Every single re-render costs something. If a component's inputs haven't changed, then re-rendering it is just totally wasted work. These tools are how you stop that waste. React Memo, Use Memo, and Use Callback, they're all just forms of memoization, which is really just a fancy way of saying remembering a result. You're just telling React, hey, if nothing's new here, just skip all the expensive work and use the last result you calculated.
And you know, performance isn't just about rendering. It's about that critical initial load time. Think of these techniques as a way to deliver your app on demand. Instead of sending this giant bundle of code and images all at once, you only load what the user needs, exactly when they need it. It's the difference between delivering a whole encyclopedia and just handing over the specific page someone actually asked for.
All right, let's peel back a layer from React and look at the language it's actually built on. This is where we get into the fun stuff, the JavaScript quirks that love to pop up as gotcha questions in interviews. All right, take a look at this, a classic interview trap. We're logging a variable before it's assigned with var. Now, your logic might be screaming, that's going to be an error, but JavaScript has other plans. So, what do you think really happens here?
The output is undefined, and the reason for this strange behavior is a core JavaScript concept called hoisting. Before a single line of your code even runs, JavaScript hoists all var declarations to the very top of their scope. So it knows that myvar exists, it just doesn't know its value is 10 yet.
And this is exactly why modern JavaScript gave us let and const. They were designed to fix this confusing behavior. Now they are also hoisted, but, and this is the critical difference, they are not initialized. They exist in what's called a temporal dead zone. If you try to access them before their official declaration, you get a much more predictable and helpful reference error.
Another classic is the this keyword. Call, apply, and bind give you total control over it. Call and apply both run the function immediately. They just have a different way of passing in arguments. But bind is the odd one out. It doesn't run the function. Instead, it creates and returns a brand new function that's permanently locked to the this context you gave it. Super useful.
For years and years, this was how we handled things that don't happen right away, like fetching data from a server. We'd pass a function, a callback, that would only run once the data finally arrived. It worked, sure, but if you needed to do multiple async things in a row, you'd end up with this deeply nested, hard-to-read code that we all lovingly call callback hell.
Promises were a revolutionary improvement, a total game changer. A promise is basically an object that represents a future value. This let us chain actions together with .then and handle all of our errors in a single clean .catch block. It just dramatically cleaned up our code.
And then came async await, which is really just a prettier, cleaner way to write promises. It's syntactic sugar, as they say. It lets us write asynchronous code that reads from top to bottom, just like regular code. You just await a promise, and the code actually pauses until it resolves. It makes complex flows incredibly intuitive.
So you might be wondering, how does a single-threaded language like JavaScript juggle all this without just freezing up? The answer is the event loop. Your regular code runs on the call stack, When an async operation comes up, it's handed off to the browser's APIs. Once it's done, its callback is put into a line called the task queue. The event loop's only job is to be like a bouncer, constantly asking one question: is the call stack empty? The moment it is, the loop grabs the first task from the queue and pushes it onto the stack to run. This is what keeps your UI responsive.
Okay, let's zoom out from the real nitty-gritty of the language to the big picture, how we actually structure a modern application so that it's scalable and easy to maintain.
One of the biggest architectural decisions you're going to make is how to handle state that needs to be accessed by a bunch of different components. React's built-in context API is awesome for simpler cases, but for large, complex apps with a ton of frequent updates, dedicated libraries like Redux or Zooston just provide more powerful and predictable patterns. This whole flow is a perfect example of a practical, real-world architectural pattern. To properly build a feature like dark mode, you don't just hack in some styles. No, you use CSS variables for your colors, you wrap your app in a provider to toggle them, and, critically, use local storage to remember the user's choice so it persists. It's a complete, robust solution. So, let's bring it all together. You're now equipped with a much deeper level of understanding. You can explain why React is fast, you know the levers to pull to make it even faster, you can navigate JavaScript's tricky parts, and you can start making those informed, high-level architectural decisions.